Hi guys, so we're going to go over Module 2 today. Some things to note, make sure that you know how to find your vertical asymptotes of a rational function as well as the horizontal asymptotes, which I put the reference table here. So using the two examples to find any vertical asymptote. A vertical asymptote is what x can never, ever, ever be. So since in a rational function, you can never have a zero in the denominator, the vertical asymptotes are simply the zeros of the denominator. So we're going to find that one value that makes a denominator of zero. So because of that, let's say in example one, to find the vertical asymptote, I'm simply going to find it by setting my denominator x squared plus 2 equal to 0. So from here, we're going to solve for x by subtracting 2 on both sides, and then x squared equals negative 2. To get rid of the square, I'm going to square root it. Whatever I do to one side, I do to the other. So the square and square root get rid of each other. X equals 2. There is no square root of negative 2 because you can't square root a negative. So because of that, there is no vertical asymptote in this given rational function. Now, for the horizontal asymptotes, what you're going to do is you're going to look at the degrees or the highest exponent for x in the numerator as well as the denominator. And then you're going to follow the table. So to find the horizontal asymptote, I'm going to make a note of what my degree of the numerator is. So x to the first power. The highest exponent or degree in the numerator is 1. And for the denominator, the degree or highest exponent for the denominator is 2. So if I look at this, n is less than m because 1 is less than 2. So referring back to the table, if n is less than m, then y equals 0. So your horizontal asymptote is y equals to 0. So these are my two answers for the rational function in number 1. Now for number 2, hopefully there is a vertical asymptote so you can see what this looks like. To find the vertical asymptote, again, it's the zeros of the denominator. So I'm simply going to set my denominator, which in this case is 2x minus 3 equal to 0. Using my algebra, add 3 to both sides, and then 2x equals 3. Divide both sides by 2, and x equals 3 over 2. So this is my vertical asymptote. This is the one value that when I replace x with that value would give me a denominator of 0, which I can never have. So vertical asymptote, 3 over 2. For the horizontal asymptote, again, I'm going to look at the degrees. So the highest exponent or degree for the numerator is 1. If x doesn't have a power, it does have a power of 1. And same thing for m here. M also has a degree of 1. So note that n is equal to m. Referring back to my table, when n equals to m, then y equals a over b, which is a is the leading coefficient of the numerator over the leading coefficient of the denominator. So y equals, I'm going to take my two leading coefficients, the two numbers in front of x, leading coefficient. So that would give me 5 over 2. And for Module 2, also note the rational zero test, which is in the video right next to it. I hope this helps.